want to welcome Amber O'Hearn.
Hi, thank you for coming. So I moved recently, and I went to the doctor to establish care in case I should ever need a doctor. And I was stymied by this intake form, which had a checkbox for well-balanced. And I thought, if I check that box, I'll be implicitly agreeing to some idea of what we should be eating that I know I don't agree with, and that would kind of lack integrity. But if I don't check the box, I'll also be implicitly agreeing to something about my diet that it's somehow not good for me, and I also don't agree with that. So I resolved this dilemma by adding my own extra box that says carnivorous, and I checked them both off. My poor, unsuspecting doctor was going over this with me, and she cares about precision in language, like I do, and so she said, "Oh, you're a carnivore." "Omnivore," she said. "My son, he says, 'Mommy, I eat meat and plants. I'm an omnivore.'" And I said, well, I blinked and took a breath and said, "Well, actually, this is my conception of a balanced diet." And I use the word balanced tongue-in-cheek because I don't actually go to any great lengths to try to balance things in my diet. I eat as much as I want from the ruminants, such as beef and sheep and goat, if I'm very lucky. And I eat pork and poultry and eggs and fish and shellfish. And that's the basics of my diet. That's pretty much all of my diet. I do drink coffee, that's my plant vice. But why? Why would anybody do this? So I think some people think that I'm just an extremist and I've fallen prey to the faulty logic where if low carbs are good for you, then no carbs must be better, right? Or some people think that I must just be a Puritan, and anybody who knows me would laugh at that. Or that I don't like vegetables, which unfortunately for me isn't true. I was sad to see them go. In fact, I was brought up vegetarian. The reason that I stopped eating plants originally was for fat loss, and the reason that I still don't eat plants over 7 years later was because it had a profound effect on my mood. Uh-oh. Okay. So let's rewind a little. I mentioned that I was brought up vegetarian, and this was lovingly balanced, planned, home-cooked meals. I did eat some meat outside the home, but it wasn't a major component of my diet. When I went to university, I initially gained a lot of weight, and going back to strict vegetarianism and even veganism and adding exercise didn't slow that down at all. I finally found low-carb diets in 1997 thanks to this book, which sent me both to the kitchen and to the library because it was full of science that I really wanted to understand, and that began a pursuit that I've followed since then. And it worked. I lost all the excess fat that I was worrying about. However, over time, I had a couple pregnancies and a lot of time had passed, and a decade later, I found myself in this position where I'd been slowly regaining, and my regular low-carb diet wasn't fixing it. So I was very unhappy about this, and so by the end of 2008, I was up 60 pounds and ready to try just about anything, and that's when I found this forum called Zeroing In on Health, where people were talking about going from a very low-carb but plant-heavy diet to a very low-carb, plant-free diet. And it was called Zeroing In on Health because even though weight loss was the major reason that people were coming to this, many people were finding that they were experiencing great improvements in their health that were unexpected, especially for strange things like autoimmune disorders, asthma, arthritis, and other things like fertility and digestion. And we use the term zero carb, or ZC for short. I prefer the term carnivore because There are foods that people on this diet would eat without hesitation, like liver or eggs or shellfish that have a non-zero amount of carbohydrate in them. On the other hand, there are things like vegetable oils, which technically have really zero carb, literally, and we wouldn't eat those. So it did work. I lost those 60 pounds effortlessly and fairly quickly. But I also found some drastic, unexpected health improvements. I had been struggling with depression since I was 20. It was a major mood disorder. Later in my 30s, I was re-diagnosed with bipolar disorder type 2, which is considered less severe because you don't have true manias. But believe me, it's a booby prize. And all of that went into complete remission almost immediately when I took plants out of my diet. Now, this was astonishing to me because even though I had come through a lot of change in thinking and going to a low-carb diet from vegetarianism, I still thought that, well, sure, maybe all of us agree that grains don't belong in a human diet or that starches might not be healthy. But what about those green leafy vegetables and all those rainbows of vegetables that we're supposed to be eating? Aren't those the very epitome of health? Before I get any further about what carnivory might be like, I want to just be sure that we are on the same terms of what I'm talking about. A lot of people call something a carnivore based on what kind of behavior the members of the species do. But the problem with a definition like that is you could argue that a domestic cat, is an omnivore because they've survived for generations on kibble that contains cornstarch. Or you could argue that deer are omnivore because they sometimes are found gnawing on bones for minerals. And any kind of definition that would end up with cats and deer as omnivores seems not satisfactory. The questions that I think are relevant for carnivory are whether the animal has a digestive system that's adapted to be able to get most or all of your nutrition from animal-sourced food, and also whether you actually have a physiological need for at least some animal-sourced food in the diet. And that definition works fine for the obligate carnivore cat, which literally can't digest plant matter. You see what happens when they ingest it, they throw it right back up. And it works for also facultative carnivores like dogs, who do have some ability to get nutrition from plants. And that's obviously a survival advantage, because then you have the ability to cope with scarcity. But just like with the cat and the deer, I think it would be misleading to call a dog an omnivore, although I know that some people do, just based on that ability, when a facultative carnivore is a much better description of their physiology. So when I ask, are humans carnivores, I'm not asking if we've been observed to eat plants, or even if we can get away with eating a lot of plants, or even if we can get some nutrition from them like the dog can. We obviously can. The questions that I think are relevant, and the argument that I'm going to make, is that we as humans have a hard requirement to get at least some nutrition from animal-sourced foods, that we have the adaptations to allow us to get nutrition, complete nutrition from animal-sourced foods. And I'm even going to argue that, at least as of yet, there's no solid evidence that we need any plant matter in our diet whatsoever. Our closest living relatives are the other great apes, and they're primarily herbivores. Herbivores get their nutrition by eating copious amounts of low-quality food. When I say low quality, I don't mean that as a personal judgment. It's a term from nutritional ecology. Primatologists have classified the structural parts of plants, like roots, stems, and leaves, as being low quality. Moderate quality food would come from the reproductive parts of plants, like bulbs, flowers, fruits, and seeds. And then high quality food would be animal-sourced food. The reason that structural parts of plants are low quality is because they're all fiber, pretty much. and fiber is not digestible by mammals. The reason that herbivores can get nutrition from fiber is that they have specialized digestive tracts where they house microbes that can digest fiber, and that fiber is digested into fat that the animal uses for energy. There are basically two ways to do it. You can either do it at the front of the digestive system. That's foregut fermentation, like sheep and cattle. They have a specialized stomach, and they chew food and it goes into a specialized stomach, and the fermentation process begins. Crucially, they're able to bring that back up, chew it, expose more cell walls, and do that over and over so that you can get this very efficient process of getting as much energy out of the fiber as possible. And then it goes through the rest of the digestive system. Hindgut fermenters, like horses, ponies, rabbits, and the other great apes, do this at the other side of the digestive tract. So you can see in the diagram, the pony here has an enlarged cecum and colon where the fermentation happens. And in the orangutan, there's a much lesser cecum, but still a very enlarged colon. And the disadvantage of this strategy is that it can only go through one time. So all hindgut fermenters get their multi-processing stage by eating the same food more than once, to a lesser or greater extent, depending on the species and the nutritional status of the environment. So what's different about humans? Why don't we eat what some people advocate, the same diet that our closest relatives do? Well, as Dr. Childers showed the same graph yesterday, this is our relative gut volume of us on the far right bar of each of these, and the other great apes are there. This is relative, so it's not the case that we grew extra small intestines, but we have essentially no cecum to speak of and very reduced colon length. We didn't get rid of our entire colon because there are other functions of the colon. Even a cat has a colon. But as Dr. Childers pointed out, we can survive without one. Now, if you have lost some function, you're no longer using it as a species. For example, a genetic trait or a piece of anatomy. What generally happens is you'll just have random loss across the species. You'll only see widespread loss of a piece of anatomy like this if there's actually an advantage to not having it. And the advantage in this case is energy. Intestinal tissue is very expensive tissue to maintain, and it just so happens that while we were evolving, we were increasing another very expensive tissue. And that's the brain. Here's what was happening. We were increasing our brain volume by 3 times. The important consequence of this was that if we gave up, or since we gave up all of this intestinal tissue, and we still needed all that energy, we needed it for the brain, and we've given up the ability to get that energy by fermenting fiber into fat. And it had to come from somewhere, and it had to come from somewhere consistently over a long period of time. Now, if we were talking about right now, where we have plants that we have bred to be more full of glucose, and where we have cooking, which developed quite late, we would be able to use possibly tubers or other plants to get that energy. But at the time of our evolution, the plants that were available were simply too fibrous and too low in protein and too seasonal to provide that over the span of the lifetime that it was needed, the span of the generations that it was needed, and the geological times that it was needed. This picture on the left shows a Hadzaman that's from a modern hunter-gatherer society that does get some of their energy from tubers. He's cooking these. They're very fibrous. They're very low in energy. And even by cooking, which we didn't have for most of that time, only about 25% of the glucose that's in there can be even extracted. Whereas, on the other hand, the animals that were available at the time were much fatter. The megafauna that we were hunting was much fatter than the lean game that's left to us now. And that was able to provide for us all the energy that we needed. And in fact, we were kind of locked into that by allowing our intestines to go away to that degree. Even a couple hundred years ago, even that recently, there were still modern hunter-gatherer societies that were subsisting on almost no plants and doing that quite well. So we're definitely adapted for that. How much fiber can we actually ferment? This picture is from Chris Kresser. It's showing what happens if you go beyond your intestinal ability to deal with the fiber. The ADA, which is generally quite fiber positive, even they suggest that you don't go over about 20 to 35 grams of fiber a day because of the gastrointestinal distress that could ensue, including cramping, diarrhea, constipation, and possibly even worse things like blockages. So a gram of fiber can yield about 2 calories of fat, and if you don't want to take in more than 35 grams a day, then that's an upper limit of about 70 calories, which for your stereotypical 20 or 2,000 calorie a day man is less than 5%. There is a larger number of 6 to 10% that's often cited, but it was actually come up with not experimentally, but by extrapolation, and I think it's quite questionable. But even if we gave them their 10%, that's not a very high amount of nutrition available out of fiber. We're very quite limited. Going back to what the brain needs, besides energy, the brain needs a lot of micronutrients that are very difficult to get from plants. This slide is from a talk I recommend by Kier Watson and Afifa Hamilton. And the micronutrients that are highlighted, even the ones that aren't highlighted here, are all ones that are critical for brain growth. If you don't get these nutrients, you can have developmental damage that will cause sometimes irreversible disability. All of those nutrients are very much available in seafood, which was the point of this slide for their talk, but all of them can be obtained from other animal products quite well, but plants are not a very good source of them. Certain of them can't be found in plants at all, like vitamin B12 or DHA. Others, they don't have the vitamin, they do have precursors, so for example, iron and vitamin A, but the amount that you would have to eat of those precursors to get the conversion, which is really low, it's tens of times more that you would have to eat. And some of them, the form is the same, but again, the quantity that's available in those plants is very low, and you'd have to eat extraordinary amounts to get it from plants. Compound that by the fact that many plants have nutrient inhibitors in them, and you may actually find yourself worse off for nutrient status. So we definitely have a requirement, because of our brains, to eat at least some animal-sourced food. Since we do need some animal-sourced food, that means plants are not sufficient. To show that they're not necessary, you'd have to know that animal-sourced foods can provide all the micronutrients we need, and that there isn't some other magic thing in plants that we need that we would need them for. Meat is completely nutrient sufficient, and I won't go into the details of every nutrient, but I'm going to just touch on vitamin C. It's the most contentious because it's one of the rare things that is more abundant in plants than in meat. It turns out that when you're not eating a lot of carbohydrate, your need for vitamin C goes down. But it's been known for a couple centuries that fresh meat by itself will cure scurvy. The amount of vitamin C that you need for scurvy, to prevent scurvy, is about 10 milligrams. And I've looked at sources that have analyzed meat and show that that's a little more than a pound of beef, for example. But this document that I have here is the report from the USDA. To add to the confusion, If you look up in a table at the USDA, it'll say that beef has 0 grams of vitamin C in it. But if you see where I've blown up these columns and rows, the report is 0. The source code there is 7, and if you look at what the source code is, it says, oh, assumed 0. So they didn't even measure that. So we can definitely get our 10 milligrams a day. The RDA is much higher than that. That RDA is based on speculation about antioxidant needs, which I think is quite misguided, because we can produce, just from our own metabolic processes, way more antioxidants endogenously than we could ever get exogenously. Well, what about fiber? I've chosen this picture because I think it's a great illustration of the false dichotomy that's usually used when people are arguing about fiber being good for you. They've got a picture of fiber going through the colon on the one hand and refined carbohydrates on the other, which really isn't a very relevant comparison. People have been trying to argue for the benefits of fiber for a long time, and every time someone proposes another mechanism, it sounds like we've got mounting evidence, even though none of those mechanisms have ever panned out. Originally, there was discussion about maybe fiber being an explanatory difference between some societies getting diverticulosis and others not. But it turns out that if you have inflammatory bowel disease, fiber is usually an exacerbation. It doesn't make it better. So it's not a very good hypothesis. There was then some talk about blood sugar going down, but that's where we're in this situation with the comparison of fiber and refined carbohydrates. Yes, fiber has less of an impact on blood sugar than refined carbohydrates, but it's hardly relevant to my diet. The other and newer idea that's come out recently is about the microbiome, how you might need to feed your gut bacteria. I think there are many reasons why I think this is a misguided idea, and I don't have time to get into all of them. But one of them is that I think it's circular. So if you're eating a lot of plants and you don't have the right bacteria to cope with all that fiber, then yes, you're going to be in a difficult position. But if you're not eating the fiber, then you don't need the bacteria to cope with the fiber in the first place. Basically, from an evolutionary standpoint, I don't think it's plausible that we could need a bacterial strain in our guts that couldn't withstand a few days of fasting, that couldn't withstand a few months of no plant intake, because I think both of those things happened. And I also find it implausible to believe that a species could need to forage for something on a continuous basis that they have no taste evolved for, and where their digestive systems have moved on to a new way of getting nutrition. I got this graphic from Nina Teicholz. The USDA has been saying things like, the obesity epidemic is not the fault of the guidelines. The guidelines are correct, but the American people just aren't following them. That's obviously not true, and that was the point of this graphic. I see a lot of outrage in this community about red meat being vilified by the USDA on the basis of what turns out to be very poor evidence. Things like epidemiology, poorly controlled interventions, and isolating compounds and giving them to animals in great quantities and proposing that those effects would be representative of actually eating meat. Well, where's the outrage about the lack of evidence on the recommendations for fruits and vegetables? It turns out that the basis of that recommendation is exactly the same kind of evidence. It's epidemiological, it's interventions where you can't tell the difference between more vegetables and more exercise or lack of smoking, and it's isolating compounds and turning them into drugs and thereby arguing that they should be good for us. The only study that I was able to find so far that has come even close to looking at the right set of conditions was an accidental experiment where what happened was the researchers wanted to find out if the antioxidants in green tea could help smokers. So they decided to take groups of smokers. They wanted to give one group the green tea and the other not, and check the antioxidant status. But they realized that there could be confounders with vegetables in the diet. So the first thing they did was got both groups to get rid of all the rainbow, flavonoid, and ascorbate-containing vegetables. And it was interesting because the green tea didn't really have any long-term effect. Again, the exogenous antioxidants. But they noticed that removing those vegetables from the diet improved their antioxidant status. So they said the decrease in protein oxidation and the increased resistance of lipoproteins to oxidation in this study points to a more general relief of oxidative stress after depletion of flavonoid and ascorbate-rich fruits and vegetables from the diet, contrary to common beliefs. Could it be that not only plants are not necessary, but they're harming us? Well, why would we expect plants to be beneficial to us? I mean, plants have the same constraints that we do. They need to survive and they don't want to be eaten, and one of their main defense is biochemical. They've been fighting herbivores, including insects, for as long as herbivores have existed. They're full of pesticides. These are just a couple of the actions that routinely are used by plants to fight their would-be assailants. For example, it might just be straight up poison that kills them, or they can mimic pheromones that are suggesting that insects should panic. They can interfere with hormones so that the animal doesn't reach maturity, or interfere with absorption of nutrients so that they also don't reach maturity. I'll just go through very briefly some of the things that are in food. I'm going to be very quick because I'm running out of time. We have alkaloids, which are in nightshades and can affect carb and fat metabolism, DNA repair, and nerve transmission. We have cyanogenic glycosides. This is Dave Feldman's cyanide diet, right? Actually, it's a major problem in parts of Africa where there's approximately 3% rate of irreversible paralysis and neuropathy due to eating this tapioca or cassava, which grows particularly well in droughts. It also concentrates the poison. An ounce of a particularly toxic sample could kill a rat. It's also found to a lesser extent in corn and apples and lima beans and flax. We've got the terpenoids, which are related to turpentine in some citrus and pepper and lemongrass. And you may have heard of these. These are the phenolics because people like these. This is the stuff that scientists are isolating and using as a drug. And, you know, that could be good in certain circumstances, but a drug has side effects, and you're not going to get, I'm sorry, but you're not going to kill cancer by eating chocolate and drinking wine. And nor would you want to have that effect in something that you're eating. I don't see you lining up for chemotherapy. And that's because the idea behind chemotherapy is just like these ideas. There's a toxin, and it's going to kill the cancer cells faster than it's going to kill your cells. The idea of balancing a diet comes from plants. Only with plants do you have to plan carefully what you're eating, because each individual plant is nutritionally insufficient, and so you have to make sure you get a variety to cover all your bases. And each one of them has its own toxins and inhibitors, so you don't want to get too many of each kind. If you're trying to plan out macronutrients, talk about a well-formulated ketogenic diet. It's much harder to do that with plants. First of all, there isn't much fat and protein in plants. The fat that's there is mostly the highly inflammatory omega-6. No amount of chasing it with omega-3 is really going to balance that out. I don't worry about macronutrients either, because, well, some people have asked me, won't you be eating too much protein to be compatible with keto adaptation? I concede that some people do need to limit protein, even past satiation, but protein is practically the definition of satiation. If you've heard of the protein leverage hypothesis, once you get a certain amount, you're done. You just want some fat. Rabbit starvation is something that has happened in real life where people don't have access to fatty enough meat and they don't feel good and they crave more fat. So I'm just going to skip to the last slide because I'm totally out of time. I want to leave you with this comment. I'm going to read it first and then elaborate on it. It's from a comment on ketogenic diets for cancer, and it's from a group from Hungary that treats their patients with what they call a Paleolithic ketogenic diet, which means either just meat and fat or almost only meat and fat. They say, we view ketosis as a physiological rather than a pathological condition. It follows on from this that the negative effects of the classical ketogenic diet, which they're not seeing, do not result from the ketosis itself, as detailed above, but from the unhealthy and evolutionarily maladapted composition of these diets. Ketosis as an evolutionarily adapted condition is generally acknowledged among ketogenic diet practitioners, but why not adapt the ketogenic diet in a way that humans were subsisting on for 2.6 million years? Once one accepts that humans are meat eaters by nature, several apparent conflicts seem to resolve. Thank you.